deformation rate tensor, we have also seen from assumption 2 that tau ij is equals to alpha ij kl ekl jkl into duk dxl. We'll use this over here, right? Now we will see the third assumption. For a solid body rotation, of fluid, there is no shear stress. Therefore, the symmetric parts will remain. Antisymmetric will be 0, which means that this portion, symmetric part, will remain and this will become 0. Therefore, this deformation rate of deformation tensor will become half dxl plus dul by dxk, right? Okay. Now the fourth assumption. The fluid is the fluid properties are independent of direction, which means the fluid properties are point functions. The fluid is homogeneous and is known as, this property is known as isotropic, right? If the fluid property is isotropic, we can write tau ij, which was earlier written as alpha, we write it as beta ijkl, because earlier it was with ekl, which was having both symmetric and non-symmetric antisymmetric parts. Now it is having only symmetric parts, so we are replacing it with beta in place of alpha, right? So beta for isotropic fluids can be written as lambda delta ij delta kl plus beta, sorry, plus mu delta I k. This you have to remember like this, ij kl for this portion, ik, this and this delta JL plus, now we will take these two and the middle ones, delta IL delta JK plus gamma into just a minus sign in between, rest all will be same. Now beta will not only be isotropic but will also be symmetric. From assumption 3, so this portion will disappear, right? So we will replace beta over here, and we will see what happens when we multiply this with this. The first term, here we have a lambda, okay. Before we do this, let me tell you why we have assumed these four assumptions. These are for Newtonian fluids. We know that for Newtonian fluids, tau is mu du by dy, right? But this is the general form of Newtonian fluids. A more simplified version is this, but this is the only viscosity term. This is the strain. Now, why are we doing this simplification? To solve this, we need uh, 81 unknowns. 81 unknowns are there. How 81? This 3, we don't know alpha, right? This 3, 3, 3, 81. From this, after all these four assumptions, we have got only two unknowns, this and this, right? These are the two empirical unknowns. Rest of the unknowns are all parametric. Now we'll see what happens when lambda wait, delta I j delta KL is multiplied with UK XL plus delta UL delta XK. We will replace, we will use only this two, this Kroneker's delta. This will be delta IJ will remain because there is no IJ term in the within the bracket, and this will become twice into delta UK and delta UK, because we will be replacing L's with K's. All the L terms will become K terms, right? Now the second term, this one, delta IK delta JL DUK DXL DUL DXK. This will become, we had a half in the front. This K will be replaced by I and L will be replaced by J. So half, and we are using both the Kroneker's delta here. Delta UJ, sorry, is I, K is becoming I, L is becoming J, L is becoming J, K is becoming I. Similarly, now if we use this term delta IL delta JK half DUK DXL plus delta UL delta XK half DUJ as you can see these two terms are the same, right? I'm so sorry. We will not have a we will not have a 2 over here. Okay, now we will replace these in this equation. We will have tau ij is equals to lambda delta ij by dxk plus mu dui dxj plus by dxi. We will stop here, right? And we will see what happens in the next video.